Bismillahirrahmanirrahim. Assalamu alaikum. I am Syed Kausandra Reddy from Mining Engineering Department 2017 session UT Lahore.
I am Tahir Mahmood from Mining 17 session T Lahore. Before heading towards the complex engineering program, big thanks to our coordinator and supervisor Dr. Zaka
who gave us an opportunity to experience a real life problem. In this complex engineering problem, our task is to carry it out the open pit slope design and verify it with the numerical and empirical design. The geotechnical department working in the sandic area performed number of tests which include geotechnical logging, geotechnical mapping and sample selection to carry out the laboratory testing. Before going to this, first we discuss the geology of the sandic area.
The Sandak quadrangle comprises of two general geomorphic provinces, the roughly hilly and mountainous areas in the southwest corner in which bedrock is exposed on much of the land surface, and the gently inclined alluvial fens and flat pebbly desert. The Sandak formation of Ion Age is made up of two general parts. The lower consists of volcanic debris, mainly water-late conglomerate, sandstone and agglomerate, and several conspicuous beds, lenses and massive reefs of limestone. The upper part consists of soft grey shale, siltstone, sandstone, marl and thin layer of limestone. Most of the formation was deposited under marine condition, but there is a suggestion of a gradual upward change from shallow water to very shallow water, or even an interradial environment. The lithology of the lower volcanic part of the formation is generally the same throughout the quadrangle. The volcanic conglomerate 1500 to 3000 feet thick contain layers of coarse agglomerate, fine volcanic sand and shale, and conspicuous lenses layer and reefs of the grey numerical limestone, from which two collections of Ion Age fossils were taken west of Sandak. Two submarine lava flows near the top of the lower part of the formation are found in the northern part of the bedded rock.
To calculate the rock mass properties of granite and norite, we are provided with the intact rock properties and we have to convert it into the rock mass properties. For conversion, we use the RockLab software. For granite, we insert the UCS of the intact rock, which is 190 megapascal, GSI value is 47, material constant is 32, and the disturbance factor for slopes is assumed to be the 1, and the modulus of elasticity is 78,000 megapascal. After inserting this value into the software, it converts the intact rock properties into the rock mass properties. The rock mass properties of the granite are as follow. The material constant is 0.726, cohesion is 0.594 megapascal, friction angle is 53.47 degree, tensile strength is 0.038 megapascal, UCS is 2.156 megapascal, and deformation modulus is 4396.57 megapascal. Similarly, to calculate the rock mass properties of norite, again we insert the UCS of norite, which is 211 megapascal, GSI is 47, material constant is 20, disturbance factor is 1, and modulus of elasticity is 109 gigapascal. After inserting this value into the software, it again converts the intact rock property into rock mass, which are cohesion is 0.575 megapascal, friction angle is 50.47 degree, tensile strength is 0.068 megapascal, UCS of rock mass is 2.394 megapascal, and deformation modulus is 6143.92 megapascal. For rock slope design, we perform the calculation of slope mass rating, which is the extension of RMR. Slope mass rating is calculated by using the four correction factors of basic RMR value. These factors depends on the existing relationship between the discontinuities affecting the rock mass and the slope excavation method. It is obtained using the following expression, that is SMR is equal to RMR plus F1 into F2 into F3 plus F4. To predict the failure, we plot the 60 points of dip and dip direction on StereoNet in dip software. With the help of dip software, it can be seen that it is a wedge failure. After knowing that it is a wedge failure, we perform the kinematic analysis on this data of StereoNet, which gives us the three joint sets, slope dip and slope dip direction. After having the joint sets of trend and plunge, slope dip and dip direction, we can compute the SMR of three joint sets. With the help of SMR sport guideline, it helps us to decide the sport system through which our lowest SMR value lies, that is 50.65. To verify the slope stability analysis of open pits and highlight the problematic areas, we draw three joint sets plane on StereoNet. As you can see in this picture, that the color diagram shows the failure areas. That failure occur in the plane between the plus minus 20 degree, and we have to install this support system given by the SMR support guidelines to these color shaded regions. To suggest the slope height and angle, we have to perform the modeling on phase 2D software, which give us the critical factor of safety and suitable slope angle. And for the slope height, we seen that when calculating the rock mass properties on RockLab software, it gives us the value of 50 meter for a single bench height, and our required pit limit is 900 meter. Hence, we have to meet 18 benches to reach at the bottom of the pit. For the calculations of slope angle and critical factor of safety, we perform number of iterations on the phase 2D software to get to the safest level. As you can see in this picture that our slope angle for granite is 31 degree and the critical factor of safety is 1.18. Similarly, for norite, the slope angle is 38 degree and the critical factor of safety is 1.1. Hence, with number of iteration, our safety factor is greater than 1, which means that our slope is safe on these angles. And we have to, our rock class is 3A and our SMR value lies between 51 to 60. So the supports we have to be installed is toe ditch or nets, sport or systematic bolting or sport shotcrete.
Hence, we perform geotechnical analysis of the given rock or sample, carried out the rock mass properties and rock classification.
which include RMR, Q system, and SMR. With the help of the SMR value, it will help us to select the suitable slope. If you really like the video, then hit the like button, press the bell icon for further informative videos. Thank you very much.